The next session will be a dialogue about AI between two colleagues called Gaurav Kakati and Omkar Panse. Let me briefly introduce those two colleagues. So Gaurav is a technology leader with more than 2 decades of experience in enterprise IT and across various roles. Currently at KPIT, he is the Chief Technology Officer for AI. And in this role, he oversees the entire strategy, the ER&D, and the implementation of AI technologies at KPIT. Over the last 6 years, he was really focusing on automation and AI. And he works with all the different business units at KPIT and ensures that AI is implemented in KPIT's all key offerings. His business goal to support our clients to integrate AI technologies into their automotive software development lifecycle. Already maybe welcome to the stage, Gaurav. Big applause. Then our second speaker is Omkar Panse. Omkar Panse is Senior Vice President and Chief Architect at KPIT, and he has more than 25 years of experience across various domains, like, for example, EE architecture, connected vehicle, infotainment, middleware, data, and analytics. Today, he's leading initiatives to drive the vehicle architectures. His special focus, EE architecture and middleware software, both onboard and offboard software. His goal, enable OEMs to unlock value through data, AI, and innovative functions. Today's topic, harnessing AI for vehicle innovation, from engineering to user experience. So welcome, Omkar, and over to both of you.
Thank you, Kati. So Omkar, as exciting as it might be, I think we are in the middle of them and the cocktails after this.
Of course.
All right, so I want to start first by telling you a small story, right? This happened a few days ago, and
Yeah.
I was in a car with a person from a younger generation, and I was reversing the vehicle, and as usual, I was just looking over my shoulder and looking at the rearview mirror, and there on the screen, I had the 360-degree camera, and the person pointed out, that you could just look at that and reverse rather than looking at it, and it just struck me how far we have come. AI has very fast entered our lives, very subtly, seamlessly, quietly. Yeah. It's in our phones, it's in our homes, it's in our cars now, and it's just gone unnoticed, but always working at the back end.
Absolutely. I mean, mobile phones have dramatically changed the technology absorption. I mean, what a 4-year kid can do today with mobile phones, probably, we might still fumble. And so the boundary between the machine and people, the human beings, I think AI is further demolishing those boundaries very, very rapidly. And it's all around us. I mean, I was seeing you gave example of the car, but in India, I wanted to buy a washing machine, right? I mean, as simple as that. But it was AI-infused washing machine, whatever that may mean. But it's all around us. And so I think mobility is not far behind, and I think it's going to touch the mobility because people's expectation of how they learn, how they consume technology, how they entertain, and how they interact, everything is getting dramatically changed. So I'm not surprised that mobility is the next frontier that AI will touch.
So now just coming to mobility, right? I think we are at a pivotal moment in automotive itself. AI is no longer an expectation. I think it's moved beyond concept. It's now embedded in how we build vehicles, how we experience them. So you take any feature from navigation to intelligent voice assistance, things like fatigue detection, or even adaptive UI. I think AI is shaping the consumer journey both inside and outside the vehicle.
Absolutely. So because the consumers are seeing every touch point and every experience point that is getting redefined with AI, and it's in their pockets with mobile phones. And as you said, I think so fundamentally, what they experience inside a vehicle as a mobility medium and the speed at which they experience and the speed at which they want to refresh. And that kind of brings us to how the technology needs to be developed and will get developed going forward with augmentation of AI, basically the engineering part of it. I think that's definitely also going to get transformed rapidly. So I think from I think Gaurav, I mean, we keep talking about it, right? From our perspective, I think it's no more about AI inside the vehicle. It's probably rethinking vehicles through AI. I mean, I think we are at that juncture already.
Yep. So let's move on a little and deep dive into some of the use cases. And I want to start with one of the most important ones, autonomy. So autonomous driving, I think Omkar has significantly evolved in the past. I would say now weeks, because that's how it's progressing. So the big shift that we are seeing now is they've moved from rule-based systems to AI-driven end-to-end learning models, right? So these systems now, they don't just follow logic or heuristics as we call it. They're learning from data, they're adapting to context, and they're improving fast. And I think that's something that's very important for safety. AI can now predict intent. So whether a pedestrian is actually going to cross the road or will the vehicle yield, these are decisions that we'll be now able to make in real time. So I think very exciting. At the same time, I think very cautious in terms of how we bring safety and security at scale.
Absolutely. And what I was thinking is, and I think Jifeng touched upon in his talk on the onboard LLM, for example, right? And why LLM and how is fundamentally changing the things. So I was just reflecting on that, and if you look at fundamentally the AI-based autonomous driving implementation has been there, but it is getting more and more end-to-end AI-based autonomy development. What is taking the world by storm is that application of LLM, and why is that the case, right? Because if you look at human thought, I think the incarnation of human thought is words, and words is language. And that's where I think the language models, in terms of what you're thinking and what you can tell and what you can get back, I think that loop and the speeding of that loop is dramatically changing how do you conceive corner cases, how do you think of corner cases. In the earlier days, I remember, there have been projects that where you collect data, you do the annotation of the data, and then you use for that. I think we are way behind that. It's imagination in terms of how do you express, and a combination of LLMs and VLMs is dramatically changing. So not just the onboard part of implementation of end-to-end AI, but also the engineering process around that in terms of validating. Having said that, we have to be very cognizant that we are still dealing with safety systems, safety critical systems, because cars are cyber physical systems, and the cost of error is huge in terms of loss of life and loss of property, right? And therefore, how do you bring it together from an engineering point of view? What kind of safety processes you put on that, and how do you integrate it into safety certification, because we can't escape that at the end of the day. That's the reality, and that's where, from our perspective, Gaurav, we see the difference in terms of how the engineering is panning out for us.
No, I think we can both agree that the goal is clear. So make autonomy happen, but I think safety is definitely going to be the important aspect.
Yeah.
How do we make it trustworthy and road ready? I think these are the aspects that we need to focus on.
Yes.
Like you said, I think with the technology evolving, with use cases transforming to agentic systems now, I think both the AI component and the engineering really needs to come together if we have to deliver this safety at scale. I think that will be extremely important.
Absolutely, and then we'll obviously touch upon it when we'll talk about the workflow and what we internally call the personas, not the agents. So it's very interesting times with that. So and obviously, and I think therefore, I think AI will help us not just implement, but probably adopt, evolve, and kind of iterate continuously. So that brings us to the favorite, something that is closer to the consumers, right? The cockpit experience or in-vehicle experience. So autonomous driving is experience, and that's a driving experience, right? But intelligent cockpit is something everybody feels, everybody touches, and everybody consumes significantly, right? And I think that is where unimaginable use cases are possible now. And I just remembered the trip I had from Pune to Goa, one of the most scenic beach place in India. and it was a rainy season, and we were driving down the hilly road, and when I came around the bend, bang opposite in the front, there was a waterfall. And I said, wow, what a nice waterfall. And my daughter was there, and she said, she talked something about it, right? And that's the moment. Now, how do you capture that moment, and what do you do in terms of bundling that as a use case and as a memory that I can live afterwards? Not possible today, but those are the kind of things a cockpit of future will make it possible. I think it's going to be deeply personalized, deeply connected, and of course, in that case, you can say almost an intelligent companion, and intelligent because it is probably still invisible. You don't have to push buttons and turn knobs to do something. It just does things, and that's what makes it exciting.
So let's take this further. I want to talk about some innovation that we might do, in terms of the cockpit. Let's call it context-aware personalization, right? So the same example, driving down the road to Goa, and there are, there are patches of that drive that can be very long, monotonous.
Yeah.
And let's assume that you've been driving alone because you're the only driver in the vehicle, and you are getting a little tired. So AI is going to be able to now detect fatigue that you have. It may adjust the ambient lighting.
Yeah.
It can even suggest which are the places that you could stop for rest,
Yeah.
or maybe simplify the UI a little bit so that if you're trying to change the songs or something, you have like a seamless experience. And what is important is how this will be enabled within the vehicle, right? This is shareable context across vehicle systems, right?
Yeah.
And so I think what is increasingly going to happen is all of the data that we collect within the vehicle, the multimodal data as we call it, things from your touch to the touch screen, your tone, the tone of your voice, your gaze, where you're looking, and all of this has to, they will then be brought into something called a context engine, right? Which is basically then going to aggregate all of this data, interpret it, create some insights, and which it is going to share with the different systems. So it could send it to the HVAC and say, hey, adjust the cabin temperature, to the lighting, and other systems, including the ADAS saying, maybe the driver's fatigue, so a little more cautious on how it's the driver's driving. So I think a lot of this is going to be possible in the near future. Lakshmi talked about the Gen 5 Qualcomm chips that are coming out. We've been experimenting with them. Some of these use cases are definitely going to be
absolutely.
possible.
And I was just reflecting on because I was part of one of the largest infotainment program, 2014-15, and I remember the nightmare of integrating the use cases and getting the use cases right. Now we are talking of next level of integration that needs to happen, which is fluid, which is subtly experienced by the user, but the magic behind that is something, as you said, we need to be focusing on. So how do we orchestrate AI workloads? How do we stitch together the context? Because all of these use cases, simple use case like when the phone call comes, lower the volume or pause the song. Now we engineered that by state machines and audio management and whatnot, right? And there's a lot of requirements, stuff goes into that, right? Now taking that to all of these, the example you gave, I think how do we orchestrate that? How do we make it aware? How do we manage the workload is going to be, is where the real beauty of engineering, if I may say, will be. And, some of the experiments, as you said, we are doing, I think, very exciting times. And there is a second point related to that is, we can talk about all use cases and all the fancy ideas, but we have to be very, very aware and cognizant that it cannot absolutely come at the cost of the safety critical functionalities and more safety critical functionalities which are going to be AI driven. So how do you do it in a responsive manner? How do you do it in a bounded manner? How do you do it cognizant of computational efficiency is where a lot of exciting stuff is
exactly.
happening.
I think benchmarking some of these AI workloads on the SOCs, the automotive grade SOCs, is definitely important. And while they have significantly improved, I think they still have limits and constraints when it comes to the cloud, because on the cloud you can run a very large model. So like you just stated, if we still continue with the same example, if you're just talking to the voice assistant asking it to change a song, but there is an emergency braking event that happens, what do you do on board at that point of time? Do you just simply stop that workload that is running for the cockpit and bring in the ADAS workload, or do you offload the cockpit workload to, let's say, the CPU and then bring in the safety critical workload into the MPU? I think these are some of the things that will be critical. The other complexity that I foresee is how use cases, which like you mentioned, were linear workflows, right, with the state machines and how we had some policies that would orchestrate them. They are becoming agentic now, right? And an agent decides what to reason, what to plan, and then what to execute. So there is no way for us to predict what kind of workload it might actually run on the chip, right?
Absolutely.
And that's an area that is like I said, benchmarking some of these AI workloads and then creating the right policies around them, resource management on the inference, and even the context, orchestration of the context is going to be extremely critical.
Absolutely, and that's where how do you build this system that is at the end of the day deployable in the production context, and that can be reasonably, you're sure that it's going to work, and that's where some of the work that we are doing in terms of can I simulate that beforehand, and can I get an idea about what's the workload going to be, so that you're really sure that, because SDV is the foundation, SDV gives us the updatability, but these additional elements, including simulation elements, will give us the predictability and confidence that it's really going to work at the end of the day. That's where the engineering challenges makes it exciting.
So I think it's the right time to switch to engineering. I think that's what the software engineering is what makes these use cases happen, right? And I think we would all agree that the V cycle, it's pretty linear. While it's a V, it's pretty linear. 80% of the defects we find only during validation, which normally we would expect to find much earlier. And this is where I think we see now the emergence of agentic AI workflows, which are being able to autonomously handle a lot of the regression work and find defects faster, right? Not only defects, but even writing software code, doing the design. These are some of the aspects that have become possible. So we have agents today that can analyze, let's say, the requirement, write the test cases, do all of the traceability, and even during the execution cycle, they can connect to the observability tools, record the traces, the network logs, and then find what is the defect in the software. All in regression, which means continuously being monitored, continuously being executed. I think Nico touched upon some of these aspects earlier. So I think it's important to understand that we are not just talking about the automation here, but it is now about intelligent orchestration, right? Absolutely. How do we bring these agents to intelligently write our software, validate them, and then make them ready for the vehicle?
Absolutely, and I think Sachin touched upon it in his talk. He mentioned we have been running AI labs, right? And there are insights. So I think one of the key things I think that kind of struck me is there are commercial tools, off-the-shelf tools available that you can start using. They can probably automate some task, write bit of code here and there, etc. But I think the challenge really is how do you bring the engineering context to that, and how do you bring that contextual understanding? And that's where I think it makes it exciting from our point of view, where ability to bring the experience of developing safety critical automotive embedded software. How do we codify that? How do we codify that as a model? How do we codify that as context? Whatever that may be, and obviously we are not going to share all the tricks of the trade, but the codification of the embedded experiences will, I think, set this apart in terms of how can you really trust it at the end of the day. And of course, it's going to be human in the loop, right? We are not like hands-off AI doing everything kind of a scenario.
Yeah, exactly. I think there are two important aspects. How do we codify the domain knowledge that you talked about, and how do we make our AI, AI tools and agents very system aware, right? So it's not about just doing the work faster; it's about doing it smarter, right? So now, of course, we have seen how our agents can understand a control loop, within powertrain, or let's say the body domain gateway. So when we have to generate test cases, when we don't even have requirements, these are some of the things we are able to do, very quickly, because like you said, we've been able to codify that domain experience and the context, which is making our systems very aware of the automotive system.
And I think, Gaurav, that's the fantastic opportunity in front of us. I truly believe, from a hard engineering point of view, we have had these tools which can be used by the developer, but I think with the codification strategies, by application of the experience, I think there is a potential to evolve this beyond a tool as a co-developer, AI as co-developer, AI as co-tester, AI as co-designer, and AI as architect across length and breadth and across the layers of the system. So I think it's going to be very exciting.
Yep.
All right, so I think here we are, and We can hear the clinking of the bottle, so we'll keep it short, I promise. So I think, but as we look ahead, as I said, I think we are looking at vehicles evolving into intelligent systems, intelligent both in terms of onboard, how do you get from point A to point B, how do you make it enjoyable, personable, comfortable, and how do you also engineer the software, right? That's what the days ahead are.
So I think, like you said, I think we have to shift from isolated innovation to some systemic industrialization of AI, right? So build frameworks that are scalable, but yet certifiable, right? We ultimately have to get them on the road, not just in our AI labs. And this is where I think continuous learning is also an aspect that we need to focus on, within the vehicle, within our labs, and across the ecosystem. So as the technology evolves, I think the user expectations will also evolve, the regulations will evolve. I think those are important aspects that we need to keep in mind.
And absolutely, I mean, and we are under no illusion that we can do it all by ourselves, right? So I think it's going to be a huge ecosystem collaboration that will be required from OEMs, tech companies, chip makers, cloud, tier 1 partners, and component providers. It's going to be yet another kind of orchestration that will make it happen.
Yep. So I think you said it right, ecosystem is going to be extremely critical. The automotive industry has always thrived on collaboration. So with AI, I think it demands a deeper integration of the domains. So, right from data ecosystems to validation frameworks, I think we have to bring everything together to industrialize AI very responsibly. So the call to action is simple. Let's move from pilots to platforms, from experimentation to execution, and let's build the future of mobility together.
Absolutely.
All right. Thank you.
Thank you.
Yeah. We can stay here, I think. Thank you very much for the great dialogue. We have now some time for questions and answers. So if anyone has, again, a question, we have here our two ladies with the microphone. So just raise your hand. Any questions from anyone?
I think everybody has ChatGPT it, so no questions.
Is it working? Chantel?
Okay. So recently, I have been thinking about one thing. It's the trend for AI, how to deploy the AI in vehicle. So just now you mentioned that we can deploy AI agents during the development, test, and validation. But when it comes to the runtime environment, maybe we can think about how to deploy AI agents for vehicle. So here, I have a question. So do you think in the future, the AI agent will be only one or multiple? So you can think, like as a human being, we only have one brain, but can run different tasks at the same time. So when it comes to the AI agents deployed to the vehicle, will it be a single AI agent with multiple threads or multiple agents for different tasks?
Yeah, so I think you may have a perspective, but I feel it's going to be a system of agents. I don't think it's going to be a single agent that will run all of this orchestration. Recently we had one of our board members also ask us this question, and the thought that was in the mind is, how will these agents interact with each other on board? Which ones run versus which ones are probably offloaded to, let's say, a CPU, which are waiting for the next task to come in. But in my opinion, I think it will be a system of agents that will orchestrate a lot of the tasks on board. Omkar, if you have...
No, absolutely. It's going to be a system, and all the points that you mentioned, they're like deep embedded topics, right? Threads and this and that. So I think that's where concepts like orchestration, balancing the workloads, sharing the context, those are going to be the critical elements. So we are doing some very interesting experiments, in that context, because we realize that that particular layer is going to be probably a critical make or break layer in terms of realizing use cases.
Thank you.
Yeah. Thank you very much. Any other questions from someone? Yeah, here.
Jifeng, simple question, please.
No, I just want to have a follow-up question. So we see a lot of agentic agent applications, and also we see a lot of multi-agent frameworks. But what is really my feeling, lack of is AI OS or generative AI OS, right? Now you have a brain who is thinking about tens of 20s of things. But when this goes to the engineering field, how would you ensure that the safety, some of the things cannot be remembered, and some of the things can be remembered. Some needs to be real time, and some needs to it's slow, but it's okay. And all of these operational systems today we have is based on the function-oriented software architecture, and now it goes to the generative AI-centric agent softwares, and that's the really rewrite of everything.
Yeah.
Yes.
So I'm not surprised we have applications, but I'm surprised who will do the AI OS, and what would be the new chance for you and the new ecosystem relationship between this OS and the application developers and the chip companies?
I think great question. So I think, and thanks for also coining that term. So because we have had vehicle OS so far, I think we'll have to look at everything from grounds up in terms of fundamentally what is meant by realizing a simple AI use case, in a simple LLM-based use case. And if you break that down into parts, and if you unfold that, we will realize there are hardware layers, there is a data layer, there is a data sharing aspect, and there is a certain execution aspect, there is a timing aspect, and freedom from interference in all of that, right? So I think the hardwares are getting there from virtualization technology point of view, but I believe a lot of work still needs to happen in terms of the intelligent data sharing, and probably not shifting the data, keep the data where it is, and can I move the AI compute around the data with a cognizance of what are we really moving and what does it mean from freedom from interference perspective. And I personally believe, I think open source will play a great role in that in terms of experimentation, and because I can take Linux kernel, I can take L4 kernel, and I can break things around. And we saw that from Li Auto, right? For example, what they have done in terms of they have modified the DDS stack like very interesting manner. But those are the elements I think will have to come together. And I think open source will be a critical ingredient in that.
And if I just add, I think open source is, I think, definitely going to be one of the places. But like you said, I think a lot of that software we may have to rewrite. We are running some experiments where we look at a lot of the agentic workloads that just simply don't run on board. They just consume too much resources just in terms of running a very simple use case. So number one, I think we have to look at some of that rewrite. The other aspect, I think, around the data is the context of the data, right? I mean, so while we have a lot of data in vehicle, there is also external context now that is coming into the vehicle. And how do we orchestrate around that? That is, I think, then deciding what are the kind of decisions these agents are taking. So not only just bringing the data from outside, creating the context, but limiting the context so that, like you said, some of the safety critical workloads are ensured that they run in a certain manner, while the rest focus on the experience on board is within the vehicle.
And certification of AI implementation is a topic in words. Starting point is obviously autonomy, because the more AI we deploy for autonomous development, even that needs certification. I think it's just going to be an expansion of that.
Good. Yeah, thank you very much.
Thank you.
So we have 30 seconds, maybe a last question, if someone has a question here in the audience. If not, then I would say big applause again to Gaurav and Omkar.
Thank you.
Thank you very much.